and 100 comparing to 49 and 51. So we need to measure the variability or spread, if you want to, we call it different names, of any data set. And you know what a data set means by now. I think Dr. Fuad mentioned to you, showed you, and then inshallah we will be dealing with data sets in the lab on a continuous basis. Okay, so now I'm going to talk about the main measure of variability. We have other types of measures of variability. We have the range, interquartile range. So we have many ways of measuring the variability, but in this lecture, I will focus on the variance, and then the other measures like the range and other measures, inshallah, Dr. Fuad will address it when he give you examples in the lab. We will talk about it. If we don't cover it, come back to us and we will, inshallah, explain it to you. I really need also to rely on you to cover all the material. I cannot cover all the material in the class. We have too much to cover. Okay, so the variance. This is a measure of variability. So if you're asking me why we're studying it, because I want to know the center of a data, and I want to know whether the data is like 49, 51, meaning all the numbers are the same or very, very similar, or the data is like 0 and 100. They are variable, even though they have the same average. Okay, so we'll start now with the data. Remember that we have to measure for the just excuse me. So the question before us is, how do we measure the data? How do we measure the variability of a data? One theory is that the best way to measure the variability is how far these points apart from the mean. So xi is any point in the data set. X bar, again, I introduced it last time, is the average of this sample, the average of this sample. So, or you can say the average of a population. So this average is the center, and we want to see how far these points away from the average. If we can measure this difference between every point and the center, then we will be able to measure the variability. And actually, that's the variability. If all points in the data, let's say all the points in the data are 50, 50, 50, 50, 50, 50. Okay, so what's the average? 50. So if the average is 50 and all the points are 50, we don't have any variability. The mean is 50. We can decide the mean. However, all data sets are not like that. They are not all the same. All data sets have different values. So we have a mean and other values. The variability of the data is the difference between these values and the mean. Okay? So how do we get to measure the variability? We know the concept of average. What is an average? We are getting one number to represent a data set. So if for a data set, if I say the average is 50, I'm mentioning to you that this data set is represented by one number, which is 50. And how did I do that? I added the values as in the mean. When we calculated the mean, we added all the values and divided by number of observations. So we can do that here also. We can see how far each point from the center or from the average, add all of those differences and divide by the number of observations that we have in the data. Okay? Now, let's do that. Let's see if that works. This is a data set, the CAM study. I'm going to stop here and say, please stop me and ask me questions if you feel that I'm not clear on some of the points, or sometimes also the broadcasting or the reception is not really well. So please stop me. Okay.
Doctor?
Yes.
Thank you for that. Can I ask you a small question?
Yes, sir.
Just about the variability. Are we trying in and then in the statics to find or to have a variable data, or are we trying to minimize the variability in the data?
It really, we will talk about it later. Right now, we are just want to measure the variability. Is it minimum or is it maximum? Do we have much variability, or I just want to know and learn about the variability in the data. Later on, we will show you that, yes, in our modeling, when we make a statistical model, yes, our objective is to minimize the variability because we really need to have a consistent estimate, but we'll talk about it later. You're a very good point. You're way ahead of us. Now, let us concern ourselves with measuring this variability, whether it's minimal or maximal. Okay.
Okay, thank you.
Great, my pleasure. So this is the data. I'm going to take the variable age and I'm going to estimate the average. Okay. Anybody is comfortable with this? X bar, meaning the average of this variable age. We listed the data, the points, and divided by the number of observation. As you can see here, we have 10 patients. That's the sample size. This is a sample from a population. We took a sample of 10 and did some analysis on this data. So I'm going to represent the data with one number. So this number represents all of those numbers. So that's the number that I have, which we call it the center or the mean. Okay. So question. So now I know from this data that the average of this data is 37.1, okay? So the average of this data is 37.1. Now, can I measure the variability in the data? How do I do it? Well, one way, as we talked about, we see the difference, calculate the difference between each point and the average. So that's what we're doing here. This is the same data set, 10 patients, and look at their ages. Patient 1, age 32 to 45. And they're, you know, down the table, down this column. So I want to estimate the deviation of these points from this. See this 37, it's the average. What we're trying now, remember, we're trying to estimate the variability of the sample. Is it two variable or is it not two variables? Now, if all of those numbers are 37.1, the variation is 0, but they are not. So what do? We take patient 1, we say 32 minus 37.1. Of course, the value or the result will be minus. So minus 5.1. 45 minus 37.1, 7.9. It's positive because 45 greater than 37. And then also, you see now, are we okay with this? How did we calculate this? 44 minus 37.1 is 6.9. Okay, so those points are the difference between in distance of code. We measure it in distance. What's the distance between 32 and 37? It's 5.1. Okay, so we calculated this, and that's our measure of variability. However, as we said before, I don't want all of these numbers. I need one number to represent the variability, just one number. So what do we do as we did before? We take the average of these deviation. So what do we call it? Average deviation. That's exactly the title. These are deviation. Deviation of what? Of age from the mean of age. And when we add them and take the average of those, become average deviation from the mean. So what are the deviation of this data from the mean? That's what I'm trying to do. So let's do it. Okay, we took the average of those, meaning added them up and divided them by 10, and the answer is 0. 0, try it. But wait a minute, I cannot move forward now. The average deviation is 0. So what do you do with 0? You cannot multiply it, you can do anything. So this method is not good. To take average deviation and move forward is not good because you get 0 all the time. And remember, every time, every single time, you take the average deviation from any mean is 0. Why is that? Because remember the mean in the center. When you take average deviation, you take all the point to the right, all the point to the left, and add them up. They must be 0. If they are not 0, the mean is not the mean, because the mean is the center. Okay? So take any data set for at home and practice it, and calculate the mean, and take the deviation from the mean, take the average deviation, it will be 0. So that's natural, because we're taking deviation from the center. So what's on the right side should equal what's on the left side, because this is the center of the data. Are we okay with this? So what do? The statistician says we have 2 ways out of this. Either takes the absolute value of this. The absolute value is the value that does not have a sign. Or we take the square of this variable, because when you square the negative, it becomes positive, as we know from algebra in high school. Absolute value is a very difficult concept, and when you add those, it will be very cumbersome. So they said, well, let's square it, because that actually, they want to get rid of this minus, so we don't have a 0 at the end. So that's what we call, by definition, the sum of or average, the sum of average deviation from the mean is 0. So either you sum them or average them, this is 0, okay? So if you sum all of those are 0 and divide by 10, it's still 0, okay? So that, remember that in any data set, if you take the average deviation is 0. Well, how do we do that? So people said, wait a minute, I have a way out of it. Let's square this deviation. So instead of minus 5.1, let's square it. It becomes 26.1 positive. So now, if we square all of them, like we did here, then this is the square. We can add them, and the value is 574.9. So now we have a number. We don't have to worry about 0 showing up every time we do the average deviation. So they call this the average square deviation. So the average of square deviation. So this is the average of square deviation. You square the deviation and take their average, meaning add them up and divide it by the number of observation. So we square from the mean, and that's what happened here. This is summation notation. In statistics, that is summation notation, meaning you sum everything in parentheses. So you sum every points in the data, you take the deviation from the mean and square it and add them up, divide by n-1. I will talk about n-1 later on. The average deviation should be divided by n-1, not by n, because remember the mean, you will be divided by n, not n-1. So please remember this fact. The only thing I'm asking you to remember is in the average deviation, we do not divide by the sample size, we divide by the sample size minus 1. So that's what we become the S square. That's why we call it the S square, or the variance. So the variance is referred to as S square. So if we take, remember before, when we added the value, it became 574.9. Divide by n-1, what is n? 10 minus 1, 9, and that becomes your value. So we call it the sample variance. Remember, is this number squared or regular number? It's a squared number because we squared, look, this is the square right there. So we need to take it back from square to regular number. As you know from algebra, you take the square root of this, and we'll talk about it later. So when you take the square root of the variance, we have a value called the standard deviation, the standard deviation. So what is the standard deviation? It's a measure of variability that can be calculated from taking the square root of the variance. Okay? Now, any questions until this point? I'm going to give you plenty of examples. Don't worry about it. I'll give you examples, but if there's any questions about the theory.
Yes, Doctor. Assalamu alaikum.
Walaikum salam.
Doctor, I didn't get how, like, why 0? How did we get 0?
Okay. do you have, take this data set, Fuad, Dr. Fuad? Is Dr. Fuad with us?
Yes, yes, Dr. Hasan.
Can you write on this lecture? Can you? I don't have with me. I cannot. So can we write on this slides?
I don't think so. Saad, do you think we can? I think you, as you are sharing it from your computer, Doctor. You are the only one who will be able to.
There should be an option to annotate.
Okay, okay. Let me see. Now,
Yes, Doctor. Yeah. Perfect.
So you are writing, yeah. So I'm trying here. I was not unable to write, but anyway, let me see if I can. Yes, I can. So I have. I'm sorry. What's your name?
Sarah Al-Jazairi.
Sarah. Okay, Sarah. I have the data set 1. Okay, I can now. All right, I'm sorry. So it writes only horizontal. This is the data set 1, 2, 3, 4, 5. Okay.
Okay.
What is the mean of this data? The average or mean of this data?
Shouldn't we add them all and then divide it by the sample size?
Yes, add them and divide them. 1 plus 2 equals 3, plus 3 equals 6, plus 4 equals 10. This is 15, correct?
Yeah.
Divided by 5 is
3.
3. Remember, we calculate. So this is 3. Now, take the deviation from 3, which is the deviation from the mean. And 1 minus 3 is what?
2.
Minus 2.
Minus 2, I mean.
Write it down.
Okay.
2 minus 3 is minus 1. 3 minus 3, 0. And then 1, sorry, and then 3. They cancel each out. All, if you add them up, minus 2, minus 1, 0, 1, 2. If you add them up, the answer is 0.
Okay. Is minus 2, minus 1, 0, and 1 and 3?
1, 2. Remember. Fuad, can you help me, please? Can you write?
Yeah, from where you get this? I'm trying to find it.
It's okay.
From where we can.
Remember, the data set is 1, 2, 3, 4, 5. Okay.
Yeah.
Take the deviation from the mean. The mean is 3. 1 minus 3 is what?
Minus 2.
Write it down. Do you have a pen and write it down, please?
Yeah.
Minus 2. 2 minus 3 is what?
Minus 1.
Minus 1. 3 minus 3?
0.
0. 4 minus 3?
1.
5 minus 3?
2.
So what do you have? Minus 2, minus 1, 0, 1, and 2. Add them up.
It's going to be 0, right?
Okay, that's it.
Okay.
So any deviation from the mean, the summation of deviation from the mean is always, always, always 0. Again, remember, what is the mean? It's the center of the data. So what's on the right, which means positive, if you add it to what's on the left, which is negative, it will be 0 because this is the center. And you can see here, minus 2, minus 1, 0, 1, 2. These are, if you add them up, those are 0. So that's the summation average. Either the summation of deviation or average. If you divide this 0 by 5, it will become 0, 2.
Yeah.
Is that clear?
Yes, thank you, doctor.
Great, great. Thank you for the question. Any other questions before I move?
Yeah, there's another question. One of the students was asking, so why don't we use the absolute value? We want positive values.
Because we are not. Okay, I have to answer it this way this time. We're not using the absolute value because it's difficult. We're using the squares because that's what we are going to teach. The absolute value can be used, but it's very cumbersome and nobody uses it, okay? Right now, all what I'm asking you is to remember the square. I'll get back to the absolute value when I'm done with this. Okay, this is an example. So what we did in the previously, we said with standard deviation. What is the standard deviation? It's the square root of the variance. Remember, what is the variance in this case? 63.88. So that's the variance that we calculated from the data. How do you calculate the standard deviation? You take the square root of 63, it's 7.99. What is 7.99? 7.99 is a measure of variability in this data set. If you take another data set and the standard deviation is 2, which data set is more variable, 7.99 or 2?
Uh, 7.99.
7.99. So the higher the standard deviation, the more variable the data is. So you see how nice this measure is? It can give you a measure whereby you can compare data 1 to data 2. All right? Good, good. So now, what is the variance in this data? 63.88. Now, what is the unit of this? Remember, we're talking about age. The unit is age squared, because 63 is a square number. Can you go, and doing research saying age square? Nobody will know what you're talking about. So the variance is always has a unit of squared unit. So that's why we don't use the variance. We use the standard deviation, because the square of this unit go back to 7.99 years. Okay? So years, we can deal with it. So that's why the standard deviation is a measure that we use, not the variance. Are we okay on this? Okay. So let's say I'm not really, I didn't understand what we did before. Well, let's get another example. This is the height of a sample that include height. Look at the left side here, height, 72, 72, 73, 76, 76, and 78, okay? Now, these are in inches, all right? Now, you can have it in centimeter, you can have it whatever you want to, but so how do you calculate the variance, which is a measure of the variation in the data? As we said, what do we do first? We calculate the mean, okay? So first we calculate the mean, which is in this case, the mean which is in this case 75, okay, 75 inches. So that's the mean in this case. How do you calculate the variance? Okay, that we do it. We take every value, take the deviation from the mean. 72 minus 75 equal minus 3. And then this one, and this one, and this one, all of them. Now, when we add these deviation, they must be 0. So if you're calculating the variance and the sum of deviation is not 0, you have to remember that you are making something wrong. Something is not correct about your analysis, about your calculation. So if this is 0, you said, okay, great. So to get rid of the 0, you square this deviation. Minus 3 become 9, 4. And then you add them up, the sum is 24. This is the sum of squared deviation. And how do you calculate the variance? The sum of squared deviation divided by n minus 1. What is n? Sample size. What is the sample size? 1, 2, 3, 4, 5. Minus 1, 4, 24 divided by 4. What is this? It's the standard, it's the variance of the sample, 6-inch squared, because remember here we squared the deviation. Is that clear? Okay, I'll take that as a yes.
So one of the students,
yes,
sorry, one of the students is asking, why would you want to eliminate the 0?
Because you cannot move. If you don't eliminate the 0, how do you move to calculate? Look, the sum of the deviation is 0. then every sample, every data set, you are going to say the measure of deviation is 0 because the sum of deviation is 0. If that's your measure of variability, every data will have 0. It's useless. It's useless. Look, the sum of the deviation is 0 because this is the variance. It's deviation from the, it's the mean, it's deviation from the mean. If you use the 0, every data set will have 0 measure of variability. Okay, so we need to get rid of the 0, so we square the unit, square them. So now we have a value 24 to work with rather than 0. Okay.
And sir, another student is asking, why is it n-1 and not just n?
And as I said, please listen to me when I say, please, I am going to explain it later. Okay. Now, before I explain the variance, it is going to be a little bit difficult. So I will explain it later, meaning later in this lecture, not later in the semester. For now, I'm asking you to memorize it as n-1. Okay? All right. So let's say we didn't understand anything before. I'm going to ask you to do this. I'll give you 2 minutes to solve it. So please don't sit and look at me, just try to solve this problem. I want you to estimate the variance of height with this data set. It's a new data set, and these are inches. Okay. All right. So let's do it together now. What is the first thing you want to do? You want to calculate the mean. Okay. This is the mean. So you calculate the mean of these values, which is 67. You add them up, divide by the number of observation, and it is 67. So then you want to estimate the deviation from the mean. Every point minus the mean. And these are the deviation. If you add the deviation, they are 0. So we have to move to the next step by squaring these deviations. So take the square of deviation, apology. Then it will be 10. The sum of the squares, we call it in statistics, sum of squares. So the sum of the squares are 10. So how do you take the average deviation? You take the 10 divided by, as usual, the average, the sum of the data divided by the sample size. However, in this case, sample size minus 1. So 10 divided by 4, 2.5 inches. So we'll say that for this data set, the measure of variability is 2.5 inches. Remember, inch is what? Square, because all of those are square. Okay? Any questions? Is that clear now?
Doctor?
Yes.
Assalamu alaikum. Right now, sample variance in the denominator. From where did we get the 5?
5 is the sample size. 1, 2, 3, 4, 5. Correct?
Thank you.
Remember that. I'm sorry, what's your name?
Tala.
Tala. Remember that what is it that I'm doing here? I'm taking average deviation. I need to, because remember we said we need one number to represent the deviation. We take average deviation. What is the average? You add the values and divide by the sample size as in the mean, correct?
Yeah.
In this case, the sample size is 5. So we divide this sum of square deviation, which is 10, by 5. But in this case, you have to say minus 1, and I'll tell you about minus 1 later on. Are we okay with this?
Okay, thank you.
Great, sure. So the standard deviation, again, for this data, you take the square root of 6, and you find, okay, so all right. Now, I'll leave you to read this. Now, let me go back and discuss with you the n-1. The n-1 in this case is a theoretical issue. When you have a data set like 65, 66, 67, 68, 69, they call it each point is a dimension. Each point is a dimension. Remember, we have one dimension, 2 dimensions, 3 dimensions. So these are dimensions of the data. Now, when we calculated the mean before, the mean, what did we do? We add them up divided by the number of observation. So we have 67 as the mean. This mean reserve a dimension in the data, meaning now I have 1 dimension of the data reserved because I calculated the first parameter or either parameter or statistic in the data. If we're talking about a population, the mean is a parameter. If I'm talking about sample, the mean is statistic. So by calculating that, I am reserving 1 dimension. So when I'm calculating the variance, remember, what did I use in the variance? I used the mean. So to calculate the variance, you have to assume that the mean is known, correct? So when the mean is known, if you don't know the mean, you cannot calculate the variance. You calculate the variance, you need the mean. So you can estimate or calculate the deviations. That's why we say that this data set should be adjusted to the fact that we know the mean. The mean is known. So it's not a dimension anymore, it was reserved. So the mean now become constant. The mean in this case does not change, 67, 67, 67, 67, 67. It's not a variable, it's a constant. So that's why the statistician will say, if we have a formula like the standard, like the variance, and using another statistic or another parameter that is fixed or known, then we have to take it out. Now, later on, you will see when we go to the analysis of variance, you have to assume that the mean and the variance are known. So you have to say n-2, because you know the mean and you know the variance. Is that somehow clear? Somebody say yes, please, or no.
Yeah, thank you. Thank you, though.
Okay. Any questions about this up until this point? So now, Dr. Fuad will give you examples after examples to calculate that. And in the lab, you don't need to worry about this. You just calculate the variance. But I just want you to know where the variance comes from. Where does it come from? Okay. So that's the standard deviation. And then there is a measure called the coefficient of variation. It's very similar to the variance. It's a way to measure variability. You take the standard deviation, you take the standard deviation and divide it by the mean. So any sample, you take its standard deviation divided by the mean, and you get the coefficient of variation. It's another measure of variability. It's not used that well. Some studies, especially in social sciences, they use it. They like to use the coefficient of variation, okay? And they usually use it to compare 2 data sets, okay? And it has no unit. Why it has no unit? Can somebody tell me why the coefficient of variation? Now the mean has unit, the standard deviation has unit, but the coefficient of variation does not have unit. So if you divide in the standard deviation, which is 6, by the mean, which is 2, and the average, the value 6 times 2 is 3, and 3 is unitless. Why is that? Well, I'm going to leave it with you. I'm going to leave it with you to find out. I think
some students are saying it's a ratio or they cancel each other.
Thank you, sir. What's your name?
It's Sama Al-Taib and Muhammad Al-Sharif.
Thank you. That's fantastic. I really appreciate that. I appreciate your participating in this, in the discussion. Yes, they cancel each other. They cancel out. Inches and inches, you cancel them out. Okay. So if you think about it, most of it really makes sense. If you think about this, the sum of deviation 0, it makes sense because we're talking about the variance, a deviation from the center, a deviation from the center, okay? So imagine a scale, and a balanced scale. So you put some weight on the right, some weight on the left, and then you could continue to balance the scale until it's balanced. What happened now? The weight on the right is equal to the weight on the left. That's why the scale has balance, which means it's 0 now. And that's why the deviation on the right and the deviation on the left, the minuses and pluses should cancel. Okay? Now, one last idea is some people like to have group data sets. What is a group data set? Look at the data set 12, 11, 12, 6, 6, 11, all of this. People say, well, that's really confusing. Why do I have 5, 5, 5? Why do I have 11, 11, 11? So what I'm going to do, I'm going to say, now, if I ask you to calculate the mean of this data, that's what you do. You add them up and divide by number of observation, like this one, 12 plus 12, divide by the number of observation, which is 10, and this is the mean. If you are dealing with grouped data, they have a different format. So the only thing we have is format. Instead of saying 12 plus 12, you say 2 times 12. No big deal. 3 times 11, 3 times 5. So that's how they deal with group data. Now, if you have a small data sets like this, it doesn't matter. But if you have a huge data sets, when you have about 12, instead of 2 times 12, when you have 60 12s, so you put 60 times 12, it makes a lot of sense. It makes it clear what we're doing. So that's group. It means instead of putting the raw data, you group them into their categories, the 11s by themselves, the 12 by themselves, the 5s by themselves. Okay. So it's just to summarize the data in a different form, user-friendly form. Any question? So now, which one do we use, the mean or the median? I would leave it up to you. I would like you to read it. And this is really, now I explained the mean and the median. I would like, this is really, that's what I will be asking you about, okay? Now, again, look at the distribution. Later on, we will go into detail on discussing this distribution. This is a symmetric from symmetry. This is right skewed. When the tail, we call this the tail. This is one tail, this is another tail. This tail, when it's prolonged, when it's stretched to the right, we call it right skewed, and then left skewed. So that these are the types of distribution that you will find. Very rarely, if ever, you find a symmetric data, unless you created this data. If you're dealing with natural data sets, they are always right skewed or left skewed, okay? This is, again, another, so look at this graph. 0 is the center. Remember, 1, 2, 3, 4, like, and then -1, -2, -3, -4. If you add those plus those, it will become 0 because if you take the deviation from the center, then it's 0. So we'll talk about it later on. Now, the distribution can be unimodal or bimodal. Bimodal, like bicycle, you have 2. So 2 modes, mode 1 and mode 2. I find this distribution very common in our classes. In the classes, especially in statistics, you find a group of people who are in this, in high, scoring high, and then a group of students who really score in average and around average. Because most of the students, either they have good background in math or not. And that's why we'll have this bimodal distribution rather than one mode. And there are other natural phenomena that have this bimodal. So the data will increase up to a point, then decrease again, then have another hump, another increase for certain reasons. So we call this bimodal distribution, okay? Now, these two graphs, look, which distribution has larger standard deviation, the blue or the red? So you can see the blue is spread way beyond this red. So that has higher variability or larger standard deviation. Okay. Now the application, I'm not going to cover today or now. We will cover them when we talk about binomial, when we talk about the binomial distribution, the normal distribution, inshallah, the next. So I'll come back to those. We have something called the empirical rule and Chevyshev's inequality, which we'll be talking about, but I'm going to come back to them later on in the semester, not now. I'm mentioning them now because they are application of the variance. They have variance in the, so they use the variance and the mean. So they are application of this data, of these concepts that I covered. Any questions?
Students, do you have any questions? You can ask.
Look, for your benefit, I am going to repeat these concepts again and again, like I am repeating don't look at the screen because I'm going to move quickly. You may get dizzy. An apology, I have to go this way, the old-fashioned way, but I have to go to this. Okay, this one. So remember, I'm repeating this again and again and again, and you get sick and tired of it. But what I'm saying here is that the concepts are new. I will keep repeating these concepts until we are familiar with them. So we have a population, we took a sample, and now we're dealing with this sample. We're estimating the average of the sample. With the average can be as mode, median, or the mean. And then this is a measure of central tendency. What is the center of this data? Another measure is the variance or the variability. So I'm calculating the variance of this data, which we call it a sample. So I'll come back and explain it when we talk about the analysis in statistics. We'll talk about, again, the mean and the variance. And Dr. Fuad also in the lab will be also talking about the mean and the variance again and again and again. So it will be, you will be familiar with the concept. I really would like for you to read this lecture and make sure it's understood. Otherwise, you will have difficulty understanding the new lectures. Okay, so today I would like you to remember the outliers from this lecture. Remember the outliers. What is the outlier? Why the outlier affect the mean and they do not affect the median? If I have outliers in the data set, which measure do I use? Do I use the mean? Do I use the median? These things I want you to remember. I want you to remember, why do we have what is the summation of the deviation from the mean? The summation of the deviation from the mean, they are always, always, always 0. And then what's the difference between the range and the variance? And why the variance is, when you get the unit of the variance, it's squared unit. That's why we take the square root of the variance and so it becomes the standard deviation. Are we okay so far? Any comments? Any? Great. So Dr. Fuad, all yours.
Thank you, Dr. Hasan.
By the way, Dr. Fuad, if there is any concept, any of the students would like to discuss it in person with me, more than happy to do that. I know that at least now when students ask me, they want to ask me, so I will stay after when you finish, I will be here so I can answer individual questions. Some of the students would like to answer, I know that. I mean, when I was a student, some of the questions I would like to ask them personally. I don't want, so yeah, I'll be here as long as it takes, okay?
All right, Doctor, we have two questions, if you don't mind.
Yes, sir, I don't mind at all.
Okay, so the first one is one of the students asking, do we consider the calculations like mean, median, or variance as descriptive statistics or interfering statistics?
That's a good question. I like that. Now, what is descriptive statistic? In descriptive statistic, we are doing what? We are describing the data. So what is it doing? Remember when we calculated the mean and the variance, what did I say? We are summarizing the data. So that's what descriptive statistics is. It's really all what we're doing right now is descriptive statistics, meaning using statistics to describe the data set. Good question. Now, look, if you see this graph that I have right now, the first part is descriptive, but look at the second part down there. It's called inference. After I describe the data in the sample, I use this description to make some inference about the population. I say, okay, this is the mean of the sample. The mean of the sample is 20. What is the inference here? The inference is that I am assuming that the mean of the population is very close to 20. Okay, does that make it better or?
Yeah, I think that made it better. Yeah, she's saying thank you. And Doctor, we have one more question. She's asking, when we square the data, it represents the deviation above and below the normal mean. Is that correct?
Yeah, because look, the deviation from the mean, they can be negative or positive because some of the values above the mean, some of the values below the mean. Why? Because the mean is the center. It has above it and below it.
All right, she says thank you as well.
Oh, my pleasure. And I would really encourage them to talk themselves, but if they are shy, that's fine. You can, you know, if they get you some, I think they should get you some coffee or you know, something nice.
Doctor?
Yes.
Assalamu alaikum.
Walaikum salam.
Doctor, why do we take the square root of the standard deviation?
Of the mean, of the variance, you mean?
Of the variance, yeah.
Okay, now the variance, what is the unit of the variance? Remember, it is, what is the variance? It is the average square deviation from the mean, correct?
Yeah.
What did we do? We took the deviation from the mean, we squared it. Why did we square it? To remove the zero, so it will not be zero. And took the average of those. So now it is the average squared deviation. So the values are centimeter square. How do you translate transfer centimeter square to centimeters?
Use the square root.
Square root. So in algebra, they told you to get rid of the square and make it the usual data, you take the square root of it, correct? So the statistician, when they calculated the variance, they say the unit of the variance is unacceptable in medicine because we don't deal with kilograms square.
Yeah.
So what do? You have to take the square root of it, and let's call it a standard deviation. So it's just a way to make the unit of the variance similar to the unit of the mean. What is the unit of the mean? The mean in kilogram, the variance in kilograms square. Wait a minute, that's not, I don't understand what you mean by kilograms square. So we take the square root of it, become the mean in kilogram, the standard deviation in kilogram.
Okay, thank
All
you.
right?
Yes.
Great. Good questions. I really appreciate the questions. Very smart questions, because it tells me that you guys, at least most of you, have understood what I was saying. Any more questions before I leave? I'm not leaving. I'm going to disappear and come back at the end if you have other questions. Dr. Fuad, it's yours.
Thank you. Thank you, Dr. Hasan. Guys, do you want to take 5 minutes break?
Yeah, they're saying, can we have a break to pray, please?
Okay, let's pray then. Then let's take 10 minutes pray and come back, please. But so we'll come back at exactly at 4:10.
Okay, everyone.
We can't hear you, Dr. Hasan, if you are talking to us.
I usually mute myself, so anyway. So we're dealing now with the final exam and stuff